And finally we have level 4. So like the other videos, we're going to have practice problems at the end of the video for you to look at. So what happens with the difference with this is there are what we call restrictions. And we'll talk about that as we go on, but let's have a look. Again, we're going to be dealing chains of events. We're just counting out the number of possibilities for positions, but there's going to be a couple of extra tricks involved. So here the first thing we're going to look at is, registration plates for cars. So you see, when you have a car, you see on the front of it, there's the plate with the numbers and the letters on it. That's a registration plate. And in a lot of countries, there's 4 digits and 3 numbers. Sorry, that should be 3 letters. 4 digits and 3 letters. Let me change that. Just cross that out. 4 digits and 3 letters. Letters, okay? So, what you're going to have is you're going to have a place for each digit. So you're going to have 1, 2, 3, 4. They're all the digits. And you're going to have 3 places for letters. 1, 2, 3. So what we're going to do is we're going to have a chain of events. We're going to have to be filling in each position one by one and then multiplying all the possibilities. So in this case, what it tells us is that digits and letters can repeat. So for example, if the letter C is chosen, it can be chosen again. If the number 7 is chosen, it can be chosen again. Okay? So digits and letters can repeat. So let's have a look. So we've 4 digits. So the first 4, the digits go as far as here, and after that we've letters. So how many options are there for the first digit? Remember, they can repeat, it says. 10. Okay? Now remember here, they can repeat, so whatever I chose in the first position can be used again. So I still 10 options. 10 options. 10 options. And you multiply. Now, we're going on to the letters. How many letters are there in the English alphabet? There's 26. So for the first position I have 26 options. But remember, whatever was used there can be used again and can be used again. Like I said before, this is going to be a huge number, so you don't have to write it. You don't have to calculate it, just write the chain of multiplications like this. Now look at this one. This one varies because it tells you that digits and letters cannot repeat. So imagine we have 1, 2, 3, 4. 1, 2, 3. I'm going to put the red here to show where the letters and the digits separate. Let's have a look. So, we cannot repeat. If you choose a certain number in or a digit in a certain position, you cannot use that digit again. So to fill the first position, we say we have 10 options. But then whatever went in that first position cannot be used again. Okay, whatever is used in the first 2, so then when we move to the third position, we've already used 2 digits which cannot be used again. So that means we've only 8 left to choose from, and so on. Then we move to the letters, 26 possibilities for the first, 25, and 24. And again, there's your chain of multiplications. Done. Next. So, again, 9-digit telephone numbers. So imagine you're living in Spain. So you have 9 digits. So you have 9 positions to fill. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So a 9-digit telephone number begins with 6. So look at the first position. How many options have I got? I've only got 1. It has to be 6. So I've only 1 choice. Now, remember, for telephone numbers in general, it tells you, we know that digits can repeat. For example, in my telephone number, the number 4 comes up twice. Alright? Actually, it comes up 3 times. Okay? So here, I just put in brackets that digits can repeat, just so that you know that they can with telephone numbers. Okay, so then I'm going to choose, how many options have I got for the second position? 10, 10, 10. Okay, so it goes the whole way down to the end. For every position, I have 10 options. So it's 1 times 10 times 10 times 10, and I should have a total of 1, 2. The first digit is only 1 option. I should have 8 tens. So 10 by 10 by 10 by 10 by 10 by 10 by 10, 8 times. What if digits cannot repeat? Okay. Have a look. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, this must begin with 6, so the first one, we've no option. For the second one, we've 10 options. Or have we? Hold on. Let me reverse for a second. So digits cannot repeat. So I've already used 6. Yeah? So 6 can't be used again. So we have all the digits excluding 6. So we've only 9 options for the second number. 8 for the third. 7, 6, 5, 4, 3, 2. There's the chain of multiplications, and that's the answer. Next example then, we have how many 9-digit telephone numbers are there which begin with 6, have 4 or 5 in the third position, and then if digits can repeat or digits cannot repeat. So let's have a look. 9-digit telephone numbers. So we have 9 positions to fill. So always think about positions to fill for a start. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Excuse me. Now, there's restrictions. That means that it tells you certain positions have to have certain numbers in them. Okay? So it must begin with 6. So the first position we have only one option. Okay? It tells you in the third position that we must put 4 or 5. So how many options have we got for the third position? We have 2 options. It can be 4, it can be 5, but it cannot be anything else. Now remember, digits can repeat, so any digits that we've used can be used again. So what we do, we fill the restricted positions first, and then we fill the rest of them. What I mean by restricted, we know that the first position has to be something, and the third position has to be something, and the rest can be anything else. So then all the rest are 10s, because in this case we can repeat. Okay, like that. And it's all multiplication. Alright. Let's look at the next example. In this case, it's the same question, except the digits cannot repeat. So we go again. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 positions. The first position must be 6, so we have one option. We have 2 options for the third position, because it can only be 4 or 5. We've only 2 numbers we can choose from. So now, the first position is filled, we've used the number for that. The third position is filled, we've used a number for that. We've used 4 or 5, we've used one of them. So now, 2 digits are gone, how many are left? We've 8 options for here, 7 for here, 6, 5, 4, 3, 2. And now stick in your multiplication symbols. Like that. And there you got it. There's your chain of multiplications. You don't need to multiply it out. And finally, is the last one before you do the practice examples at the end. So let's have a look at this. So I have 5 desks at the front of the room. 1, 2, 3, 4, 5. And I'm going to fill them with students. Now obviously, because of the type of question it is, so, sorry, I got interrupted there. So what I was saying was that because we're choosing students, obviously they can't repeat. You can't have one student in the first seat and have the same student in the second seat, unless they're a magician or magic or something. So here's the thing with this. This is tricky. So, I actually left out a bit of information which I'm going to include. So we're going to say that in the class, 24 students to choose from. We'll say that there are 10 girls, 14 boys. Okay, I forgot to add that in the question at the start, but I'm putting it in now. 10 girls and 14 boys. So, 5 desks, 24 students. How many possible arrangements are there? If the first seat must be occupied by a boy and the second seat must be occupied by a girl. So the first seat has a restriction. That means that there's something special about those 2 seats, the first and the second. We can't just choose anybody. We have to choose a certain type of student. So we're going to look at the first one. 24 students. I want to choose for the first seat, and the first seat must be occupied by a boy. So how many options have I got? I have 14 options for the first seat. Okay? Why? I'm not choosing out of 24 because then I could choose a girl or a boy. I have to just choose out of the boys for the first seat. For the second seat, I must choose out of the girls. Okay? So now, seat 3, 4 and 5 can be girl or boy, it doesn't matter. So how many options have I got for the third seat? Well, how many are there in the class in total? There's 24. How many of them have I used? I've used 2 already. Okay? So that means I have 22 options for this, 21 options for this, and 20 options for that. Multiply, 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 multiply. So let's let me go through that one more time. The first position must be a boy, so when I'm choosing for that position, I can't choose out of the 24 from the class because then I'd be choosing out of boys and girls. I have to choose out of 14 boys. Second position, I'm choosing out of the 10 girls, so I have 10 possibilities. And then for the rest, for the third position, okay, I filled the first 2 positions, so 2 students are gone, so I have 22 students left to choose from, so I can choose from girls and boys. Okay? So you do 22 by 22 by 21 by 20. Practice problems. So how many possibilities are there for each event? So a registration plate with 4 digits and 3 letters where all the digits are the same and all the letters are the same. Now that's a tricky one. So again, line up the positions and how many options have you got for each one. How many 5-digit numbers are possible where the first digit is 2, the third digit is 3 or 7, and the last digit is 8 or 9. So we're going to do it twice. We're going to do it where digits can repeat and then do it where digits cannot repeat. How many ways can I arrange the letters of the word maths, M-A-T-H-S, if the first letter must be S or T and the fourth letter must be A or H? So what I'm suggesting here for your notebooks, I want you to write these questions into your notebooks and then attempt them, and then you can check them with me.